This is for test 1, part 1, the extra credit assignment. I'll be starting with question number 1. In order to find the right variables, we must compare these equations. And we will compare it to this. So, in the first equation, $100 is the x initial. The velocity initial is 5. And we do not have our acceleration. So, x initial equals 100, velocity initial equals 5. In the next equation, x2 t equals 3 plus t squared. Our 3 represents our x initial. Our velocity initial isn't there, so it's 0. And our acceleration can be found here as the value 1. So x initial is 3. 1/2 a equals 1, which means acceleration is 2. When do they have the same x? When does this equation equal this equation? So first we'll make them both equal to each other. Then we will subtract 3 from each side. It'll be 97 plus 5t equals t squared. And then we'll subtract t from each side so that we have negative t squared plus 5t equals 97. And with this, sorry, not equals 97, plus 97 equals 0. And with this, we can use the quadratic equation. Negative b plus minus Now, because it is plus minus, we have two scenarios. One equals negative 7.65 and the other is 12.65. And because time is always positive, this is the time that these two equations have the same x. Now, we must find out what time the velocity of object 2 is equal to the velocity of object 1. And in order to do that, first we know that our v1 is given as 5. And that is in the first equation, x1 equals 100 plus 5t. v2 is different. The equation would be this. We know that acceleration is 2 and that the initial velocity is 0. So v equals v0 at, v2 equals 0 plus 2t, v2 equals 2t, and v1, if we make them equal to each other, then it would be 5 equals 2t, and t would equal 2.5, and that is the time the velocity is the same. If we wanted to draw x1, it would look something like this. If we wanted to draw x2, it would look something like that. If we wanted to draw v1, it would look a little something like that. v2 look like that. And then acceleration, when it is 0, it'll look like that.